Have you ever wondered what music would sound like if it wasn't born from wood? For centuries, the luthier's craft has been synonymous with tone woods like spruce, maple, and rosewood. But what if we broke free from that tradition? What if we could craft instruments from materials you'd never expect to sing? That's exactly what we're doing today. We're stepping into a world where music is made from the unconventional, the overlooked, and the downright bizarre. Get ready to have your ideas about sound completely reshaped. Our journey begins not in a forest, but in a recycling facility. Piles of plastic bottles, containers, and packaging. This is our raw material. Most people see this as waste, but we see it as a symphony waiting to happen. The first challenge? Turning this pile of discarded plastic into something solid and workable. We started by shredding mountains of PET plastic, the same kind used for soda bottles. Then, using a combination of heat and compression, we melted these shreds into dense, solid blocks. Think of it like a high-tech, eco-friendly version of woodworking. The goal for our plastic experiment was ambitious: a fully functional acoustic guitar. The key properties we were chasing were resonance and durability. Plastic is interesting because its density can be controlled. By adjusting the pressure and temperature during the molding process, we could create a material that was strong enough to handle string tension, yet light enough to vibrate and produce sound. We crafted the body from a high-density recycled plastic block, carefully carving it into a classic dreadnought shape. For the neck, we used a composite made from recycled plastic mixed with fiberglass for added rigidity. This was crucial to prevent the neck from bending under the immense pressure of the steel strings. The soundboard, the heart of the guitar's voice, was the trickiest part. It needed to be thin and responsive. We experimented with a different type of polymer, one known for its flexibility. After several prototypes, we landed on a thin sheet of recycled acrylic. The moment of truth came when we strung it up. The sound was astonishing. It wasn't warm and woody like a traditional guitar, but bright, crisp, and surprisingly loud. It had a unique character, a percussive attack with a clear, bell-like sustain. It proved that beauty in music can indeed arise from what we throw away. This plastic guitar isn't just an instrument. It's a statement about sustainability and the hidden potential in our waste. Next, we moved from the light and pliable to the heavy and unyielding, concrete. Yes, you heard that right. Concrete, the stuff used to build skyscrapers and sidewalks. The very idea seems insane. How could something so dense and rigid possibly create music? It's known for absorbing sound, not producing it. But that's exactly the kind of challenge that excites us. Our inspiration came from an obscure instrument called the lithophone, which is essentially a xylophone made of resonant stones. If rocks can sing, why not concrete? Our mission was to build a concrete cello. This was an immense engineering challenge. The first step was creating the right concrete mix. Standard concrete would be far too heavy and acoustically dead. So we developed a special, lightweight aggregate concrete, mixing in materials like perlite and vermiculite. This reduced the density without sacrificing strength. We then created a complex mold for the cello's body, designed to be hollow, just like its wooden counterpart. Reinforcing the thin concrete walls with carbon fiber mesh was essential, to give it the structural integrity needed to withstand the string tension. After weeks of careful curing, we demolded our creation. It was a beautiful, brutalist piece of art. It was heavy, no doubt, but manageable. We fitted it with a traditional wooden neck and fingerboard for playability because some things are classics for a reason. But the body, the resonant chamber, was pure concrete. The sound was unlike anything I have ever heard. It was deep, haunting, and resonant in a way that's hard to describe. It didn't have the warmth of wood, but instead, it had an ethereal, cavernous reverb. Each note lingered in the air with a ghostly presence. Playing it felt like drawing music from the earth itself. The concrete cello is a testament to the idea that with the right design and a bit of audacity, even the most unlikely materials can be given a voice. Our sonic exploration didn't stop there. We turned our attention to the delicate and fragile world of glass. Glass is fascinating because it has incredible resonant properties. Just think of the sound of a crystal glass ringing. We decided to create a glass flute. This wasn't a simple glass tube. We wanted to craft a transverse flute, complete with precisely drilled tone holes. We worked with a master glass blower who used borosilicate glass, known for its strength and thermal resistance. The process was mesmerizing, shaping the molten glass with breath and gravity. Each tone hole had to be placed with mathematical precision to ensure the flute would play in tune. The result was a stunning, transparent instrument that looked as beautiful as it sounded. The tone was pure, clear, and almost otherworldly. It was brighter than a metal flute and had a unique, airy quality. The notes seemed to float, shimmering with complex overtones. Playing it required a delicate touch, but the reward was a sound of unparalleled clarity. It felt like playing an instrument made of solidified air and light. This experiment taught us how a material's internal structure directly translates to its sonic signature. The uniform, amorphous nature of glass created a pure, focused tone that was simply magical. From glass, we ventured into the world of metal, but not in the way you might expect. We weren't building a trumpet or a saxophone. We decided to build a violin, an instrument almost exclusively associated with wood. We chose aluminum for its lightweight and corrosion-resistant properties. Using CNC milling, we machined the top and back plates of the violin from solid blocks of aircraft-grade aluminum. The design had to be completely reimagined. We couldn't just copy a wooden violin's dimensions. We had to calculate the optimal thickness and arching to allow the metal to resonate properly. We incorporated a lattice-like internal bracing pattern, inspired by modern architectural design, to control the vibrations and prevent harsh metallic overtones. When we finally assembled the aluminum violin, it looked like something from the future. It was sleek, metallic, and undeniably cool, but how did it sound? It was powerful. The projection was incredible, easily filling the room with sound. The tone was bright and focused, with a sharp attack and a long, singing sustain. It lacked the complex warmth of a fine wooden violin, but it made up for it with its own unique voice, a voice that was modern, clear, and assertive. It's the perfect instrument for genres like electronic or rock, where cutting through a dense mix is key. It showed us that the soul of an instrument isn't just in the material, but in the intelligence of the design. Our final experiment was perhaps the most organic of all, even though it didn't involve wood. We turned to mycelium, the root network of mushrooms. Mycelium is an incredible natural material. When dried, it becomes lightweight, strong, and surprisingly rigid. It's also completely biodegradable. We partnered with a biotech company to grow mycelium blocks and custom molds. Our goal was to create a set of hand drums, like bongos. We grew the mycelium around a substrate of agricultural waste, like hemp and sawdust. After about 2 weeks, the molds were filled with a dense network of fungal fibers. We then baked the forms at a low temperature to stop the growth and solidify the material. The resulting drum shells were incredibly light, almost like styrofoam, but astonishingly durable. We fitted them with traditional animal skin heads. Tapping on them produced a sound that was earthy, warm, and deep. It was a tone that felt ancient and primal. The mycelium had a natural dampening quality which gave the drums a tight, focused thump without any harsh overtones. It was the perfect sound for rhythmic, percussive music. This project felt special. We weren't just building an instrument. We were collaborating with nature, growing a sound from the ground up. It's a glimpse into a future where our products could be grown, not manufactured, creating a truly circular and sustainable economy. So, what have we learned from this journey into unconventional instruments? We've learned that music is not confined to wood. It's a universal force waiting to be unlocked from any material, provided we are creative enough to find the key. The plastic guitar, the concrete cello, the glass flute, the aluminum violin, and the mycelium drums, each one has its own unique voice, its own story, and its own soul. They challenge our perceptions and open up a universe of new sonic possibilities. This isn't about replacing traditional craftsmanship, it's about expanding it. It's about showing that innovation and sustainability can go hand in hand, creating a future where music is more diverse, more surprising, and more in tune with our planet. Thank you for joining us on this incredible adventure. What material do you think we should try next? Let us know in the comments below, and don't forget to like and subscribe for more sonic explorations.